a budget-friendly and affordable electric vehicle doesn't have to feel cheap. Right now, the Tesla Model 2 is proving this with 7 new updates designed to make everyday driving smoother, safer, and more practical. From gliding over rough roads to seeing clearly in cold rain, charging anywhere without adapters, handling maintenance smartly, staying safe when parked, and resisting rust through harsh winters, these are not just features, but a redefinition of what a budget-friendly electric vehicle can feel like. Which of these upgrades will instantly make daily driving more comfortable, and which will quietly save money over years of use? This video will walk you through each update that almost no one has talked about on the Model 2. Don't wait to catch up later. Subscribe now to help Autofusion hit 9,000 subscribers. And remember to turn on the bell so you don't miss the deep dive into each of these new upgrades coming right up. The Tesla Model 2 tackles one of daily driving's biggest annoyances with a pothole protection system using a front camera that scans at 60 to 120 frames per second paired with vibration sensors near the wheel hub. Information flows to the suspension controller, which recognizes dark spots, sharp edges, and sudden vibration spikes. Within just 10 to 15 milliseconds, the computer adjusts how stiff the shock absorbers are, and total system delay stays around 50 milliseconds, fast enough to soften the suspension right before impact. At the same time, the Model 2 slightly reduces regenerative braking force, so the wheel isn't locked when it hits a sharp edge. When the shock absorber softens at the right moment, the up and down impact force at the hub can drop 20 to 40%. For instance, at 40 km per hour over a 5-centimeter pothole, peak force can fall from 8 to 10 meters per second squared to about 5 to 6 meters per second squared. That means less stress on the tire sidewall, fewer bulges or cuts, and lower strain on alloy rims. In seat tests, the average vibration at the driver's seat drops 10 to 25% on medium rough roads, making the Model 2 noticeably smoother and less tiring in city driving. The savings are real. Typical 17 to 18-inch tires cost $150 to $220 each, and replacement rims $300 to $900 including balancing. One bad hit could cost $250 to $1,200. With annual mileage of 12,000 to 15,000, this pothole protection system can reduce serious tire or rim damage by 30 to 50%, saving several hundred to over $1,000 in 3 to 5 years. Each pothole is also recorded locally and, if the owner agrees, anonymously added to a shared Tesla map that lets the Model 2 anticipate known rough spots in future drives, creating a smarter, smoother experience over time. What's the worst pothole hit you've ever had? Under $250, between $250 and $500, or over $500? If you think a system like this would be worth it for your next car, comment Tesla Model 2. The Model 2 tackles visibility at the source by treating water and fog right on the camera lens. The system starts with a special water-repelling coating that delivers a contact angle of 115 to 120 degrees so raindrops bead and roll away instead of smearing. Around the lens sits a 2 to 4 watt micro heater ring that raises the glass surface by 8 to 12 degrees above the outside temperature within 10 to 15 seconds. When the onboard humidity sensor detects a risk of condensation, micro-air jets sweep across the lens at 6 to 10 meters per second to push away moisture. In practice, individual droplets clear in 0.2 to 0.4 seconds, while a thin fog layer typically disappears within 5 to 8 seconds. These elements work together so the camera lens returns to clarity quickly and predictably. That restored clarity translates into better information for Model 2 driver assistance. With fewer watermarks and less haze, the cameras preserve the contrast that computer vision models need for lanes, vehicles, and pedestrians. In controlled testing, moderate rain reduced blurred frames by 60 to 70% once the storm vision system was active. In light fog, the share of frames meeting a high contrast standard rose by 30 to 45%. As a result, lane keeping and forward object detection remain online longer instead of dropping to backup sensors. Braking tests at 60 km per hour in light rain showed automatic braking identifying obstacles several frames earlier, trimming stopping distance by 1 to 2 meters. Such gains matter when hazards appear. Even with the performance improvements, energy cost stays minimal. Each storm vision cycle uses only 0.02 to 0.05 watt-hours, an amount that is negligible relative to the battery pack. During dry conditions, the system rests in standby and periodically checks humidity, then stays off. Drivers notice steadier alerts and guidance. The net effect for the Tesla Model 2 is a vision suite that stays clear without driver effort, lowers visual strain on long wet drives, and keeps advanced safety and convenience features operating consistently through weather that normally degrades camera-based systems. Tesla Model 2 integrates its power switching gear and the charging communication module directly inside the inlet. So every decision happens at the source rather than through an external accessory. The moment you plug in, the software pulls the pins, A handshakes with the charger and automatically detects the standard in use, whether that is combined charging system, North American Charging Standard, or International Electrotechnical Commission Type 2. It then negotiates voltage, current and safety parameters in about 2 to 4 seconds. A mechanical lock clamps the connector to maintain alignment, and a temperature safeguard cuts power if the plug shell exceeds 65 degrees Celsius. Because the logic and relays sit in the port, there is no adapter software to update, and no extra contact resistance to heat up under high current. Those design choices show up clearly on the power curve. At a 400-volt charger, Tesla Model 2 sustains about 120 to 170 kilowatts until roughly 50% state of charge before power begins to reduce. With liquid-cooled 500-ampere cables and a preconditioned battery, peak power rises to 200 to 250 kilowatts and the car reaches 100 kilowatt output in 6 to 8 seconds. That ramp is roughly 30 to 40% faster than arrangements that route through an external adapter, which often require an extra handshake and add a second set of contacts. Fewer interfaces also mean fewer faults. On large public networks, charging session errors fall under 1% because the car and charger speak directly without a translator in the middle. Translate those numbers into a day on the road and the benefit is easy to feel. On a 600-kilometer trip with 3 short stops, total plug and wait time typically sits around 45 to 55 minutes. Instant protocol recognition alone saves 6 to 10 minutes, which is about 10 to 15% shorter stops. Holding higher charge power for longer trims another 2 to 4 minutes. Add it up, and a Tesla Model 2 driver can save 10 to 14 minutes on a single long trip. Avoid the hassle of carrying adapters and get transparent billing because every protocol runs natively inside the car. The result is simpler road trips, faster turnarounds, and fewer uncertainties at unfamiliar stations. Tesla Model 2's predictive wear monitoring system is a quiet watchdog that listens and feels for early signs of wear every time the wheels turn. Each corner carries a small microphone and a vibration sensor mounted near the hub and control arm, sampling noise and vibration thousands of times per second, while temperature and humidity sensors provide context for road and weather conditions. Over time, the system learns to spot reliable clues, high-pitched squeals around 2 to 6 kHz that often accompany dry brake pads, and low-frequency vibrations around 12 to 18 Hz that point to uneven tire wear. Using these signals, it estimates remaining tree depth with a target accuracy of plus or minus 0.5 millimeters on dry pavement and infers brake pad thickness from friction and heat patterns. When confidence clears a preset threshold, the Model 2 recommends a tire rotation or a quick inspection directly on screen so owners can act before small issues grow. Those prompts translate into practical savings. Rotating tires as soon as the front to rear tread difference reaches 1.5 to 2.0 millimeters can extend tire life by 10 to 20%. On a $600 to $900 set of 18-inch tires, that means saving $60 to $180 each cycle while keeping grip more consistent. Replacing pads early at 3 to 4 millimeters remaining helps keep rotor temperatures below 350 degrees Celsius, which avoids warping that can cost $300 to $600 per pair of rotors. Plus, this predictive wear system spotted uneven wear 25 to 35% earlier than a traditional mileage schedule, yet kept false alerts under 3% by cross-checking sound and vibration against localized weather data. For owners who cover 12,000 to 15,000 miles per year, the Model 2 can consolidate maintenance into one major visit and one quick touch point, trimming total garage time by 30 to 40%. Over 3 to 5 years, typical savings from timely rotations and pad replacements land around $300 to $900 with the added benefit of smoother braking, steadier steering feel, and fewer surprise shop visits. The best part is that none of this requires deep technical knowledge. The Tesla Model 2 simply listens, learns, and nudges at the right moment. Tesla Model 2 now functions as an interactive repair manual that rides with the car, turning routine fixes into clear, guided tasks. In service mode, the touchscreen lays out step-by-step procedures, torque specifications in Newton meters, color-coded wiring diagrams, and fault code translated into plain language. Diagnostics are accessible through onboard diagnostics or an open application programming interface, so independent garages can follow the same workflow used by official service centers. This typically cuts troubleshooting time by 20 to 40%. With labor rates of $90 to $150 per hour at independent shops, and $150 to $250 per hour at dealers, that translates into roughly $200 saved on a standard repair. Safety is built into the access model. High-risk operations such as software updates require two-factor authentication, while most everyday procedures remain read and follow with on-screen confirmations. Every action is logged to preserve warranty integrity, and technical bulletins, procedures, and torque tables update over the air, ensuring a garage always sees the latest specifications for Tesla Model 2 without paying for yearly document packages. The time savings show up in common jobs. Fixing a stuck window motor on a Tesla Model 2 typically drops from 2 to 3 hours to 45 to 60 minutes, a labor reduction worth $150 to $300 at typical rates. Replacing the 12-volt auxiliary battery falls from about 70 minutes to 30 to 40 minutes thanks to guided isolation of the high-voltage system and a checklist that prevents missed steps. Spread across several small repairs per year, owners often reclaim 2 to 4 hours of shop time and $180 to $600 in labor. Quality improves alongside speed as repeat visits for the same minor issue within 30 days fell by 25 to 35% when garages use service mode. For Tesla Model 2 owners, that means fewer return trips, more predictable costs, and the confidence that even a neighborhood shop can service the car correctly using factory-aligned instructions. The Tesla Model 2 goes beyond basic alarms and locking pins by hardening the very moment of entry. Its ultra-wideband key authentication measures the travel time of radio pulses rather than their strength, which defeats the classic relay attack that fools conventional keyless entry systems. The cryptographic handshake, typically completes in under 10 milliseconds and proximity, is verified with position accuracy in the 10 to 30 centimeter range. So a key that is not physically near the vehicle does not pass. Because ultra-wideband relies on time of flight instead of signal strength, simple signal boosters cannot fake it, which raises the bar for thieves who depend on inexpensive relay hardware. This makes the Model 2 significantly more resistant to the common tricks used against standard keyless entry. If a criminal manages to move or hide the vehicle and cuts its cellular data link, the Model 2 shifts to a second layer called mesh recovery. In this mode, the car sends out short, range-encrypted ultra-wideband pings that nearby Tesla vehicles can hear and forward to the cloud once they regain cellular coverage. Each relay hop adds only a few seconds, and the effective search area grows from tens of meters to hundreds of meters as more cars participate. That mesh approach is especially powerful in dense urban neighborhoods and multi-level parking structures. Even if cellular signal is jammed near the stolen car, the local mesh can still spot it as other vehicles pass within range and later upload the sightings. The combined effect is a meaningful reduction in successful theft and a higher chance of recovery when theft does occur. Insurers often recognize this reduced risk with small premium discounts since exposure to theft goes down. Just as important, the Tesla mobile application alerts the owner as soon as another vehicle relays a ping, displaying a nearby location dot and encrypted status, so the situation is clear and actionable without guesswork. Rust prevention on the Tesla Model 2 starts from the material itself. A special coating applies a 3-layer treatment on steel components like control arms, link rods and bolts, 6 to 8 micrometers of electrovinized zinc, 1 to 2 micrometers of conversion coating, and 12 to 18 micrometers of polymer top coat. Salt spray tests show 720 to 1,000 hours of resistance, about 2 to 3 times better than standard paint. This means Model 2's joints and fasteners stay solid even after years of rain or road salt. To handle trapped moisture, Tesla adds humidity and salt-ion sensors in the fender wells that trigger release vents when moisture stays above 85% for 30 minutes. The vents open for 2 to 3 seconds, draining 15 to 25 milliliters per second, and close automatically once dry. This prevents rust pockets from forming in hard-to-clean areas. In real maintenance tests, specially treated bolts on the Model 2 need up to a third less force to remove after 2 winters. This shortens service time and can save around $80 to $100 per visit while also preventing costly part replacements over time. The Tesla Model 2 isn't just adding features. It's quietly rewriting what affordable driving feels like day after day. Comfort, safety, and intelligence now come standard in ways that used to cost extra. Which of these updates would you want on your next drive? Let us know below.